video is on dividing a polynomial by a binomial. So for example, we have a polynomial, so more than one or more terms being added or subtracted, and it's being divided by a binomial, that means two terms. So to divide it, we are going to set it up just like a normal division. We are going to use long division for this class. So x squared plus 10x plus 21 divided by x plus 3. So before we start here, let's compare it to if we were dividing 475 divided by 5. So 5 goes into 47 9 times, and then we multiply these and we get the product, which is 45, and then we subtract, and then we bring down the next number, and 5 goes into 25 5 times, and then 5 times 5 is 25, and we get a remainder of 0. We are going to do the same similar process here. So we need to know x, how many times x goes into x squared. Now there's a trick. It will always be, if what's inside here is a 2, then what goes up here is always going to be 1 less than this. So if this is x squared, then this is going to be x, because x times x is x squared. In other words, we wanted to know, just like this, how many times 4 goes into 47 times, or how many times 5 goes into 47, 9 times. Well, we wanted to know how many times does x go into x squared. So x goes into x squared if we use our exponent rules and we subtract them. 2 minus 1 is 1. So that's why the little trick works. So then we're going to take this, just like we took 9 and multiplied it by 5. Well, we have x plus 3 here. So we need to multiply the x, we need to multiply it to the x, and that's where we get x squared, because we are adding the x, we need to add the exponents when we multiply. And then we also need to multiply it to the 3, and that is positive 3x. Then we subtract. So x squared, take away x squared, so in other words 1 minus 1 is 0. But then here we have 10 minus 3, which is 7x. So after we subtracted, then we brought down the next number. So we are going to bring down the positive 21. And then we need to ask ourselves, how many times does x go into 7x? Or another way to think about it is x times what is 7x? Or again, you could think of it this way. How many times does x go into 7x? 7 times. Positive 7, because 7 times x is 7x. So we always want these to be the same. And then 7 times 3 is positive 21. And then we subtract. These will always be the same. They will always cancel out and make 0. Then we have 21 minus 21, which is 0, just like here. So this one has a remainder of 0 as well. So the answer is this right here. The answer is x plus 7. Now, the answer for this problem was 95. And if we wanted to check it, we could take 95 and multiply it by 5. We could take these two and multiply it, and we should get 475. So 95 times 5 is 475. Well, same thing here. We should be able to take x plus 7 and multiply it by x plus 3. So if we want to check it, we could take x plus 3 multiply it by x plus 7, and it doesn't matter which one goes first. And if we multiply this, we have x times x, add the exponent, so that's x squared, and then we have x times 7, that's 7x, positive 7x, and then 3 times x, that's 3x, and then we have 3 times 7, which is positive 21. And then we can combine these like terms here and get 10x, bring down the 21, bring down the x squared, and as you can see, we get this right here. Here. So the nice thing about these is that you can always check them. So again, there's a little bit of strategy or tricks here. So just like if this is a 2 here, then this is always 1 less, the exponent here. If this has 3 terms, then the answer is going to have 1 less, so 2 terms. So let's go ahead and try another example. Okay, so this one is a little bit different. In this problem here, when we divide, we need to make sure the polynomial is in standard form. If we take a look at the one that we previously just did, it was in standard form. So the one with the higher exponent was first, and it is in descending order. So in other words, 2, then 1, and then the constant. Whereas this problem is not in standard form, so if we put it in standard form, the negative 7x squared would go first. And then we need to make sure all the terms are present in descending order. So we have 2, and then we need one with a 1 as an exponent. There is no term with a 1 as an exponent here. So we are going to need to fill it in as 0x, because 0 times anything is 0, so it's okay to put this term here. So 2, 1, and then the constant, the one without the variable, goes last, and that is a positive 8. So we need to make sure that it is in standard form and that all the terms are present in descending order. Okay, so we have 3 terms here, so our answer will have 2 terms. This starts with a 2, so this is going to be 1 less, so this should be x. And I want what times what is negative 7x squared. So if we put a negative 7 here, then negative 7x times x is negative 7x squared. So remember, these two always have to be the same. So the number you put here, when it multiplies to this, should make that the same. So that's how we knew to put the negative 7 there. Or the other way to think of it is we want to know how many times x goes into, how many times it goes into negative 7x squared. So if we do that, you'll see that you would get negative 7, because negative 7 over 1 is just negative 7, and then 2 minus 1 is just x. So that's also how we could figure out the number that goes there. So then we have to also multiply it to the negative 8. So negative 8 times negative 7x is positive 56x. And then we subtract. And then we have negative 7x squared take away negative 7x squared. So negative 7 minus negative 7. That makes 0. That's why these need to match up so they cancel out. Then here we have 0 minus 56. So 0 minus 56 is negative 56x. Then we bring down the 8. So x goes into negative 56x, or you could think of it as x times what will be negative 56x. So negative 56. So negative 56 times x is negative 56x, so again these should line up or be the same. And then negative 56 times negative 8 positive 448. And then we subtract, and these cancel out because negative 56 minus negative 56 is 0. And then 8 minus 448 is negative 440. So here we don't get a remainder of 0 like we did in this problem. So if we were dividing, let's go back to division without variables. If we were dividing this problem, 3 goes into 4 once. Bring down the number. 3 goes into 14 4 times. 4 times 3 is 12. 3 goes into 23 7 times. And we get a remainder of 2. So when we get a remainder, if we don't want to change it to a decimal, which we're not here, what we do is it's 147 and 2/3. In other words, if we check this, if we wanted to check it, 147 times 3 is 441. It's not the number in the inside here. So this 2 represents here that we need to add on 2 more. So the remainder we need to add on to our problem. And now we get 443. So this says 147 and 2/3. So here we get negative 7x minus 56. And then we have to include, and since this is a negative, we could put a negative here, and then 440 over, so the remainder goes in the numerator, just like it did here. The 2 was the remainder. And then this number here went in the denominator. So the x minus 8 in the denominator. Another way to write this is negative 7x minus 56 plus, and then the negative 440 over x minus 8. Either of those are correct, or the same thing. So if we want to check this, we would do x minus 8, this times this, so we got negative 7x squared, negative 56x, positive 56x, and then positive 448. This makes 0, so we're left with negative 7x squared plus 448, which is definitely not what we started with. What's in the inside? We have negative 7 we have negative 7x squared, but we have positive 448. We're supposed to get this. Well, that's where the remainder comes in. The remainder was negative 440, so we have to now include that. And if we do, now we get 448 minus 440 is positive 8. And now we get what we started with, negative 7x squared and positive 8. So that is what this stands for. This stands for that when you multiply this with this, when you multiply these two, the answer you get, you have to then subtract in the remainder, or add in the remainder. Okay, let's go ahead and do one last example here. Okay, so we need it in standard form, so the highest exponent first. So we need 4 and then we need 3, so none of them have an exponent of a 3, so I'm going to put a 0 as the placeholder here. So 4, 3, and then 2 goes next. And then 1, none of them have just a y, so I'm going to put 0y, and then the constant goes last. Okay, so since this is a 4, this is going to be 1 less, so this is going to be y cubed. So y cubed times y is y to the 4th. Y cubed times negative 1 is negative y cubed, or negative 1 y cubed. Then we subtract 1 y to the 4th, take away 1 y to the 4th, that's 0. These should always make 0. They should be the same. Then we have 0 minus negative 1. 0 minus negative 1, that makes positive 1 y cubed, or just y cubed. Then we bring down the next number, 6y squared. And then we have to ask ourselves, y times what is y cubed? So if this is 3, the next one should be a 2. So y squared times y is y cubed, so 1y cubed. And then y squared times negative 1 is negative 1y squared. And then we subtract 1 minus 1, that's 0. And then we have negative 6 minus negative 1. So again, negative 6 minus negative 1. That makes negative 5y squared. Then we bring down the next term. Okay, y times what is negative 5y squared? So it should be an 3, 2, so this should be a y, but that would get me y squared. This times that is y squared. I need the negative 5. That's how I know I need this to be a negative 5y. Because when I multiply negative 5y by y and add the exponents, you would get negative 5y squared. So you always want this to multiply with that to get the same thing so they cancel out. The negative 5y times negative 1, this times this, is positive 5y. And then we subtract. Those cancel, and then we have 0 minus 5. And 0 minus 5 is negative 5y. And then lastly, we bring down the 3. And y times what is negative 5y? So we have 3, 2, 1. Then this one should not have a variable. It should just be a constant of negative 5. Because negative 5 times y is negative 5y. And then negative 5 times negative 1 is positive 5. Then we subtract, these will cancel, and then we have 3 minus 5. And 3 minus 5 is negative 2. And we have no other terms to bring down, so we are done, and we have a remainder of negative 2. So our answer is all of this. So y cubed plus y squared minus 5y minus 5, and then the remainder is negative 2, and the remainder goes in the numerator, and the y minus 1 goes in the denominator. Or you can write your answer like this. So if you wanted to check this, you can multiply all of this by y minus 1 and then subtract 2.